Assalamualaikum and a very good day. Today we will continue the lesson for chapter 6, which is section 6.4, regression line. After we sketch the scatter diagram that we learned before, when we can see the obvious trend of linear relationship, next we might interested to determine the equation of line that best fit with the data. So linear regression is a method use a model or generate a mathematical equation to describe the relationship between these two variables. Whether is two variable or more variable by fitting a linear equation to observe data where we use the least square method. This method is another method to help in finding the relationship between two variables. The least square method is the accurate way to find the best line fit. This red line is the best fitted line from the plotted data. The difference between the observed value, which is all the point here, the observed value, and fitted value show in the graph, which is referred as D1. So the difference between the observed value and also the fitted value, which is in red line, is called residuals. Okay, so D1, D3, D4, and so on is all called residual or error. So the most important in least square method is we want to minimize the sum square of the error. So the least square regression line of x and y for a set of data in the form of y bar estimated y equal to a plus bx. Estimated y equal to a plus bx. So sometimes we call it as y equal to mx plus c. So the constant value of a here is the value of y where the regression line intersect with the y-axis. Okay, so if you have an x and y-axis, a is the value when the line intersects with y, which is when x equal to 0. Okay, it can be either in any direction. Okay, so this is referred to value of a where the y intersect with when the line intersect with the y-axis, while b is the slope of the regression line. So the regression line with a positive slope, positive slope indicates that there is a direction relationship between x and y. In other words, as x increase, y also increase. Okay, so if you have a regression line which is in a negative slope, if we have the slope as negative y, estimate of y equal to a minus bx, so we have a slope show a negative value, so it indicates inverse relationship between x and y. So as x increase, y will decrease. If the slope is 0, it means what we can say, we can interpret the relationship between x and y is 0. So the value of a and b in the regression equation, y estimated y equal to a plus bx, it can be calculated using the following formula. Okay, so you have b and then all the formula, and then a is summation of y over n, or minus b summation of x over n. A equal to y bar minus b x bar. Okay, so n refer here number of pair of data, summation of x, summation of y, you sum all x. Here you sum all value of y. Okay, x bar meaning that the mean of value of x. Okay, you have a summation of x divide with n to get the mean. Okay, and then mean of y meaning that you are finding summation of y divide with number of pair of data. This one. Okay, and then you summation of x squared, you find every x squared item in the data and then sum all the results. Same goes to y. So find all y squared and then total up everything. Okay, and then you also have here summation of x squared. Okay, summation of x squared. So meaning that this one is squared here, squared here. Okay, square of the sum of all the values of variable x or y. Okay, let's look at example 4. A group of engineers wants to determine the stress level at which a wing component on an aircraft will fracture for a given fractured toughness. Table below show the temperature and impact energy data tested on temperature steel alloy. Find the least square regression line for the following data. Okay, before you start, you have variable for temperature and impact energy. It is important for you to know which one is independent and which one is the dependent variable. So as we can see here, impact energy depends on temperature of the tempered steel alloy. Therefore, the temperature is independent variable in the x-axis and impact energy is the dependent variable in the y-axis. Okay, because impact energy depends on temperature. So see, now we already determined our x and y. So it is important to know which one is your x and which one is your y before you start calculating to find the least square regression line. Okay, you need to find all the information, summation of xy, summation of y, summation of x, summation of y squared, and total net. You have total data is 15, summation of x squared. So all the value, after you get all the value, just substitute in the formula. Okay, next, after you find this, you can find the value of a. Okay, this is the mean of y. Substitute your b, what you get here, and then mean of x, then you get all the value. So we have the least square regression line is y bar equal to 74.4097 plus 0.2784x. Okay, from the equation we can see the slope is positive. So from here we can say that this equation have direct relationship between x and y, or we can say direct relationship between temperature and impact energy on tempered steel alloy, because our variable is on temperature and impact energy. Okay, next let's look at the exercise. The investigator of a factory was asked to investigate the factor that caused the breaking strength. Two factors that influence the breaking strength of a synthetic fiber are being studied. One of it is the age of machine. It affects the performance of productivity. 10 samples of machine were took in holding the investigation. The result of the investigation is recorded as below. Okay, so you can pause this video and try to do this exercise before looking at the answer. Okay, when you want to start, you must make sure what is the independent variable, what is the dependent variable. Okay, pause and try to check which one is independent and which one is the dependent. Okay, from the exercise, we can see that from the problem, breaking of synthetic fiber depends on age of machine. Therefore, age of machine is the independent variable which is in the x-axis. Meanwhile, breaking of synthetic fiber is a dependent variable in the y-axis. Okay, so you calculate all the necessary working, okay, and find that the value of summation of x, y, and so on. Substitute in the formula for b and a. So you get this square regression line. Okay, so again, you can see that from this equation, the slope is positive. So from here, we can say that the equation have direct relationship between x and y. Or you can say that it has a direct relationship between age of machine and breaking strength of a synthetic fiber. Okay, now after we are finding the regression line, the most important skill that you must have is to know how to interpret the results. You should not only know how to calculate, but you must also should know what the value of the calculation is all about. What is the value of A all about, what it tells you about the data, what is the b or the slope tells you from the data. Okay, so how to interpret for a? So we already simplified for you what is a, meaning a refer to intercept of axis y. Okay, so it means that when x equal to 0. So what it means, you must know what is your variable x. So when there is no value, meaning that x equal to 0, when there is no value of variable x, when x equal to 0, the value of the variable x, no value in x, then the value of variable y is value a. It means that the value of variable y, if y is strength of machine, meaning that the value of strength of machine is the value of A. Okay? Okay, when we say about you want to interpret of a slope, so we can say that every 1 unit increase in variable x, okay, every 1 unit increase in temperature, for example, will increase the value of what is your variable y. Just plug in variable y by what is the value of the slope. Okay, or you can see that every 1 unit increase, here the value of the slope can be either positive or negative value. So okay, let's say you have y equal to 2x 20 plus 3x. So meaning that the value here should be positive 3. So if you have a negative here, so the value for this by negative 3. So other way to interpret B is by every 1 unit increase in variable x, okay, just plug in what is your variable x, will increase or decrease depends on the slope sign. Okay, if increase meaning that positive sign, if decrease it have a negative sign, and then the value of variable y, just substitute what is your variable y by slope unit. So slope ni here you will just put by 3 unit if we compare with this equation. Okay, we will look at the example later. Okay, let's look at example 5. Refer back to example 4 and then interpret the value of A and B. Okay, so we look back how you want to interpret for E and B, okay, from your previous notes. Okay, check back what is the variable of x. So variable of x is the temperature, and then the variable of y is the impact energy. Okay, so what you can see between these two, temperature and impact energy. Okay, we see first by following this way how to interpret. Okay, when the temperature, when there is no value, so in the case of X temperature, we can see that the temperature is 0. Okay, when the temperature is 0, then the value of impact energy is 74.4097 joule. Okay. The value of variable Y. What is your variable Y? Impact energy. So the value of impact energy. Okay. So you already interpret for A. Okay. For interpret for the slope. Okay. Every 1 unit increase in variable X. So what is the unit of variable X? Your variable X is temperature, and the unit is in degree Celsius. Okay, so every 1 degree increase in temperature will increase the variable Y, which is value of impact energy by 0.2784 joule. Okay. Okay, it seems goes to here. The same thing with this. Okay. The thing is only if let's say we have the B now is negative. Okay, for example only. Okay, B is negative 0.2784. So what we can say, while if we interpret like this way, okay, while every 1 degree increase in temperature will increase the value of impact energy by negative 0.2784 joule if we follow this. Or another way of interpreting it, let's say you want to use this way. Okay, the same thing. While every 1 degree increase in temperature will, because this is negative now, will decrease the value of impact energy by 0.2784 joule. So no need to put negative here. Therefore, you can directly tell your client or who you want to report this. You understand that it will decrease when the value of X increase. Okay, when the temperature increase, the value of impact energy will decrease. Okay. Okay, so it's up to you how you want to interpret this. Okay, next looks at exercise 5. You can try to pause this video and try to do it yourself. So your A is equal to 123.4, B equal to 4.3091. Okay, again, okay, let's refer to how you interpret A and B. Okay, what is your X variable? Is age of machine, and your Y variable is breaking of synthetic fiber. Okay, what you can interpret from A, okay, when the machine is new, or which is means the machine is the age is 0, then the breaking of synthetic fiber is 123.40, while every 1 year increase in usage of the machine, the breaking of synthetic fiber will increase by 4.3091. Okay, just follow the format here. Okay, other than that, predicting Y value using, we can use a regression equation and predict the Y value. So linear equation is one of the techniques used for predicting the unknown value of a variable from the known value of another variable. It means that if the x and y are two related variables, then from regression equation will help us to predict the value of y. Example 6. So by referring to the data in example 4, the regression line is given by the following equation. So let's say we want to predict the impact energy on tempered steel alloy if the temperature is 80 degree. So we know that temperature is the x. So x equal to 80. Then you just substitute 80 to the equation and get the answer. Hence, if the temperature is 80 degree, then we can predict that the impact energy on tempered steel alloy will be 96.6817 joule. Okay. For for B, predict the impact energy on tempered steel alloy if the temperature is negative 200 degrees Celsius. Okay, so substitute all the value in the equation. So hence, if the temperature is negative 200 degrees Celsius, then we can predict that the impact energy on tempered steel alloy will be 18.7297 joule. Okay, now looks at exercise 6. Pause this video and then do it yourself. After that, you can compare with the answer. Okay, again, now you need to compare the data of exercise 3, which is the regression line is given below. Predict the strength of steel if the heating time is 29 minutes. So, since 29 minutes is in the range of value that we'll use to find the regression equation, then we can use the equation to predict the strengthness of the steel. So, when x equal to 29, then you substitute in the regression line, which is a unit of strength. Hence, the heating times is, and if the heating time is 29 minutes, then we can predict that the strength of the steel will be 68.4433 unit of strength. Okay. Predict the strength of steel if the heating time is 120 minutes. So if x equal to 120 minutes, substitute in the value. So you get 273.8 8758 unit of strength. Next, let's look at exercise 7. Okay, this is referred to exercise 4. Go back to your notes and look at exercise 4. Okay, predict the number of breaking of the synthetic fiber if the age of the machine is 5.3 years. Okay, since 5.3 years is in the range of value that we use to find the regression equation, then we can use the equation to predict the number of breaking on the synthetic fiber. Okay, once we get this value, so what we can say that if the machine is 5.3 years duration used, then the number of breaking on the synthetic fiber is 146.2382 units. So B, predict the number of breaking on synthetic fiber if the machine is 70 years. Just substitute the value and get the answer. And now let's look at 6.5 coefficient of determination. The coefficient of determination is normally denoted by R squared. The coefficient is the ratio of the explained variation to the total variation. The coefficient of determination is the square of correlation coefficient R. So what we get R before coefficient or correlation of coefficient, when we square the value, that is called coefficient of determination. So the term of r squared can be expressed as a percentage. So the formula for r squared actually is given as below. R squared, or we call it coefficient of determination, is equal explain variation divided with total variation. But you just need to find R. We have the formula for R, which is the correlation coefficient before. So you calculate your R and then you find the squared value of the R. Okay, how you want to interpret the R squared coefficient of determination is just by using this standard way how you want to interpret the R squared. R squared percentage of the variation in the variable y can be explained by the relationship between variable x and variable y. So the remaining variation is unexplained. Okay, so you need to just plug in the percentage value of r squared in terms of percentage, remember? Okay, and then just change the plug in the what is your variable y, and also just change here what is your variable x and variable y. Okay, and then the remaining value of this percentage variation is unexplained or does not related with the variable. Okay, let's look at the example. Okay, example 7. A group of engineers want to a study was done on the stress level at which a wing component on an aircraft will fracture for a given fracture toughness. Table below show the temperature and impact energy data tested on temper steel alloy. Calculate the coefficient of determination of R squared for the data and interpret the result. Okay, so this is your value of X and this is value of Y. Okay, so you know your variable for X and variable for Y. So you can start calculate the R. Okay, so finding the R using the formula before, your R equal to 0.9356. Then the coefficient of determination is just the squared value of this value. So how you want to interpret this result? Okay, so let's say this is your standard way how you want to interpret the coefficient of determination. Okay, so from here we try to okay, remember the x value previously is the temperature, y equal to impact, and y equal to impact energy. Okay, your x is temperature, y is your impact energy. Okay, so this is the standard way how you want to interpret this. So let's look at how we interpret this. Okay, the value of r squared equal to 0.8753 indicates that, okay, 87.5 in terms of percentage. So you just multiply with 100. Okay, so you get 87.53% of total variation. Okay, a total variation in y. So variable y is the impact energy, can be explained by the relationship between temperature and impact energy, variable x and y. Okay, so the remaining of 12.47%, this is just 100% minus with the 87.53%. Okay. So you get 12.47% will be explained by other factor, okay, which is unexplained by the factor of temperature and impact energy. Right, next, let's look at exercise 8. Okay, by referring to the exercise 4 previously, okay, so compute the coefficient of determination of r squared. So let r equal to 0.9650, then the coefficient of determination is r squared, the value of r. So you get the coefficient of determination equal to 0.9313. Okay, again, this is your general interpretation for coefficient of determination. Okay, so let's check back your exercise 4. From exercise 4, your x, sorry. Okay, your x equal to age of machine and y equal to breaking of synthetic fiber. Okay, so you know your x and y. So the value of r squared equal to 0.9313 indicates that the 93.13% of the total variation on the variable of y, which is number of breaking on the synthetic fiber, is explained by the relationship between age of machine in yearly and number of breaking synthetic fiber. So the remaining 6.87% will be explained by other factor. Okay, so make sure you know how to interpret the coefficient of determination and also correlation coefficient. Okay, now let's look at last subtopic, which is data analysis. Okay, let's look at example 8. Let's look at here, steel is normalized by heating above the critical temperature. Soaking and cooling an experimenter want to give the effectiveness of the time consuming in heating on the strengthness of the steel. Okay, we have time consumed, okay, which is our variable x, and strengthness of steel is your variable of y. If we use Microsoft Excel to process the data, we can get the summary of the data as follow. From the summary here, what you can see, this is multiple of r, so this is your r squared. Okay, and then you can find your slope here, and the intercept value here. Okay, so this is your slope, this is your intercept value. So you can find the least square regression line from this summary output. Okay, so estimated of y equal to 29758 plus 2.2575x. Okay, so from here, when the time consumed is 0 minute, then the strengthness of steel is this one. If you want to interpret, the question is you need to interpret the look back at your book. The question asks you to interpret the regression line. Okay, when the time consumed is 0 minutes, the strengthness of the steel is 2.9758, while every 1 unit increase in time consumed will increase the strengthness of steel by 2.25, which is the slope unit. Okay, check back how you want to interpret your A and also your B value, which is the slope. And then if you want to predict the level, the strengthness of the steel of 11 minutes, so substitute in the regression line. So you get 27.8083. Hence, if the time consumed is 11 minutes, then we can predict that the strengthness of the steel is 27.8083. Okay, let's say you want to predict in 100 minutes of the time consumed. So you can just substitute 100 minutes in the equation and find and get the estimated value. Okay, for E, so the same thing, finding R and R squared. Okay, you can find R. You can find R from the some output summary. Okay, this one, and the R squared for from this output summary. Okay, so your R equal to 0.9894. Okay, by looking the summary output, and then the R squared equal to 0.9790 from the summary output. So from this R, you can interpret that there is a positive linear correlation between time consumed and steel strengthness. And then the value of R squared equal to indicates that 97.90% of total variation on steel strengthness can be explained by time consumed, and 2.1% will be explained by other factor. So again, exercise 9, try to do it first. Again, you have the summary output, okay, and then see what is the result. So you have R here, R squared here, okay, your intercept, and also your slope value. Okay, so you get the equation, okay, from the summary output, then interpret value of A and B from here. When the duration time of engine service is 0, the injuries will be 29.397. If the owners delay the service by 1 year, the level of injuries will increase by 0.168 times. Okay, C, you need to predict the level of injury if the service duration time is by 5 years. Okay, so the prediction of Y, okay, substitute 5 in the equation, you get the value. So what you can say, if the service duration time is by every 5 years, then we can predict that level of injury is about 30.237 times. Okay, set the R and R squared and interpret the meaning. So we get the value of R equal to 0.760 from the summary output. And then what we can interpret, there is strong positive linear correlation. Okay, remember how to look at this value, how we want to say this is a strong or weak. Okay, since it falls under 0.760, so it have a strong positive linear correlation between service duration, time, and the level of injury. Okay, and then you get 57.8%. So there's no answer here, but you must just compare back how you want to interpret the coefficient of determination. Okay, I forgot to write down the answer. So you just can say this means that what is the percentage of variable in variable y can be explained by the relationship between variable x and variable y, and then the remaining of the variation is unexplained.